Hello everyone. The title of this video is Add or Subtract Complex Numbers. Alright, all the exercises I'm going to be doing in this video are taken directly from a free online textbook at openstax.org, and it's their Intermediate Algebra 2nd edition text. I'll be working under the heading Add or Subtract Complex Numbers. I'm only going to be working on exercises that are even numbered, right? Ones that don't have solutions that you can click on and see. Right? The odd numbered problems, you can click on the numbers and see the solutions in the text, but the even ones you can't. So I'm going to be working on the even numbered ones. In the description of this video, you will also see timestamps for each example I work on, and each example will correspond to a different question. Right? So example 1's timestamp will take you to number 414, example 2 to number 416, example 3 to number 418, and so on all the way to number 428. And one thing I request of you while watching this is that when I bring up a new question, pause the video and try to work on it yourself first. Right? Then watch me do it and compare. Because if you're just watching me do these questions without actually practicing yourself, chances are you're not learning all that much. Alright, so the first question, number 414, I have written out on some paper. And we're simply asked to add or subtract the complex numbers. So before we get into the actual question, I want to talk about what are the complex numbers. Right, the complex numbers are basically every number we're going to talk about in this intermediate algebra course. The standard form of a complex number. Every complex number can take the following form: a plus b times I, where a and b are real numbers and I, if you recall from a previous video, I is that imaginary unit. Remember, I is the square root of -1. Right. So this is what every number can be written as. Right. Every number we can think of in this intermediate algebra text can be expressed in this form. Right. And as I said out loud, and I'll write it here, this is the standard form of a complex number. Right, but notice what this is. You have a real number plus an imaginary number. Right, if you recall from my last video, any number of this form, where you have a real number times I, right, times the imaginary unit, that's an imaginary number. Right, so every number we can think of, right, every number from this intermediate algebra text can be expressed as a solely real number plus a imaginary number. So every number in intermediate algebra here, so every number we deal with in intermediate algebra, or I should just say college algebra, basic college algebra, is a complex number. So for example, just a few examples, all the real numbers are complex. Take 1, that's real. You can express 1 as 1 plus 0 times I. Right? There's a real number plus a real number times I. Right? And 0 times anything is still 0, so this is still equivalent to 1. Pi is a real number. Can be expressed as pi plus 0i. In fact, any number that's strictly real can be expressed as that number plus 0 times I. Same thing for the imaginary numbers. Right? If something's strictly imaginary, like I, you can still express it in this standard form as 0 plus 1i. Right? A real number plus a real number times I. Negative 4i, imaginary, is 0 plus negative 4i, or 0 minus 4i. Real plus real times I. And in fact, any number that is strictly imaginary can be expressed in this standard form by simply adding 0. And then any combination of reals and imaginaries is complex. 2 plus 3i, real plus real times I, that's a complex number. Negative 4 minus pi I, that's a complex number. Square root of 3 minus the square root of 5 times I, that's a complex number. The cube root of 2 plus the fifth root of 3 times I, that's a complex number. I could do this all day long. As long as I fill in A and B with a real number, and we have a real number plus a real number times I, we have what's called a complex number, and everything is a complex number. Everything can be written in this form. Alright. Now, when we're asked to add or subtract, you just add and subtract like you would with polynomials. You add reals with reals and terms with I with other terms with I. Right? It's just like combining like terms. Alright. And then one more thing I need to point out. One more thing we need to recall here, and this is from a previous video as well. So I'm going to put recall, hopefully you remember this. That if, say b is a positive number, then the square root of negative b, remember the square root of a negative is imaginary. We are going to automatically rewrite this as an imaginary number, as the square root of just b, right, the square root of a positive, a real number, times I, where, again, I is the square root of negative 1. So please keep this in mind as well. Whenever you see the square root of a negative number, you're going to rewrite it as an imaginary number, as a real number times I. So that's what I'm doing here. All right. So number 1, finally. Number 1, which is exercise 414 in the text. The square root of negative 12, I'm going to rewrite as the square root of 12 times I. Plus, and then the same thing with the square root of negative 75. The square root of a negative number is imaginary. I'm going to rewrite that as the square root of positive 75, right, a real number, times I. And make sure that the I is not inside the square root. All right, then simplify. The square root of 12 is 2 times the square root of 3. All right, square root of 4 times the square root of 3. And then don't forget times I. Plus, and then the square root of 75 is 5 times the square root of 3. Right. Square root of 25 times 3. Right. Times I. And now I combine like terms. We add or subtract, but here it's adding. See how both these terms have I, right? So you could factor I out if you wished. Take 2 square root of 3 plus 5 square root of 3 times I, right? You're just combining the coefficients of the i's. And you could leave it like this if you want, but these radicals are, like radicals. They both have the square root of 3. So I can put them together. 2 root 3 plus 5 root 3 is 7 times the square root of 3 times I. And there we go. That's our final result. That's as simple as that gets. Okay. Now, if we want to check our work, we can use a calculator. And I'll show you. I have a TI-84 emulator that I'm going to be using. Okay, and here we go. I've pulled up. This is a TI-84 Plus emulator. Now, if you notice right now, where it says normal, float, auto, it says real. So the outputs need to be real numbers at the moment. So if I tried entering the original expression, say the square root of negative 12 and then plus the square root of negative 75, right, it's going to come back to me with an error because those are not real. Right, see, non-real answers. So if you want to avoid that in this particular graphing calculator anyway, hit the mode button, and then if you look down here a bit, you see where it says, let's move the cursor, it says real, and you see right next to it, A plus BI, you see that flashing? A plus BI. Go to that mode, and then quit, and then I'll put the last entry I put up, the square root of negative 12 plus the square root of negative 75, and now what it's going to do, it'll actually give you complex answers. It'll give you answers with the imaginary unit I involved. Watch. See, 12.12435565 times I. Now let's see. That was the square root of negative 12 plus the square root of negative 75. It's 12.124i, right? We put here that this should be 7 times the square root of 3 times I. Well, let's see what 7 times the square root of 3 is. 7 times the square root of 3. And look at that. It's 12.124355565. It's this number, but then, times I. We needed I there. So we're correct. This 7 times the square root of 3 times I is equivalent to the square root of negative 12 plus the square root of negative 75. Alright, so again, now I'm in this A plus BI mode instead of real mode. So that way, if answers aren't real, they will actually pop up on without giving me an error. They'll actually show up with that imaginary unit I. Wonderful. Alright, so continuing on. Question 2. A very similar problem to exercise 416. The square root of negative 72. Again, make this automatic. Right? Make this automatic. Anytime you see the square root of a negative number, rewrite it as an imaginary number. Right? This is the square root of positive 72 times I. Right? Plus, and then the same thing with the square root of negative 8. I'm going to rewrite that as the square root of positive 8, right, a real number, times I. Now, simplify the radicals, right? The square root of 72 would be 6 times the square root of 2. All right, it's the square root of 36 times the square root of 2. And then times I, plus, and then the square root of 8 is 2 times the square root of 2. All right, the square root of 4 times the square root of 2. And then don't forget the times I. And now comes the addition part, right? Just combine like terms. Both of these have I in common, so I can combine their coefficients. 6 root 2 plus 2 root 2 is 8 times the square root of 2. And then don't forget the times I, right? I would have done what I did up here, factored out the I, and then just combined the coefficients. All right, and once again, let's check it out. I'm going to pull that calculator back up. I'm going to enter the original expression, right? Make sure I'm in this, A plus BI mode and not real mode, right? And I'll put in the square root of, negative 72. Then plus the square root of negative 8. And you see it's 11.3137085 times I. Okay. Now let's see if that's equivalent to our final expression. Now we said this should be equal to 8 times the square root of 2 times I. Well, I've already got the I there, so let's see what 8 times the square root of 2 is. And look, it's that 11.3137085, right? So this is what I want, the 11.3137085 times I, 8 root 2 times I. Fantastic. Okay, so you're going to keep this stuff in mind. And when you're adding and subtracting, you're just combining like terms. You combine real numbers with real numbers, and imaginaries with imaginaries, right? I terms with I terms. That's all you need to know. All right, so the next question. Now here we don't have square roots of negatives, but we do have, imaginaries. We have the I. And like I said, you just combine like terms. This is 6 plus 2i plus 3 minus 4. I'm just going to, 6 plus the 3 would go together. Those are the real numbers. Plus 2i, then the positive 2i term and a plus negative 4i. Right. So you combine real numbers. Right, you combine reals. And you combine imaginaries. It's just like adding polynomials, right? You wouldn't put a term with x with a constant, right? You wouldn't 2x plus 6 you wouldn't put together. Same thing with the i's. You treat I like a variable even though it's not a variable, right? Because it's a square root of negative 1. Combine reals. Combine imaginaries. And we're done, right? So 6 plus 3 is 9. And then 2i plus negative 4i would be minus 2i, right? Or you could write plus negative 2i. And this is it, right? This is as simple as it gets. And when dealing with complex numbers, the answer should be in standard form. Right, I wrote the standard form earlier. A plus bi or minus bi, right? If b is negative, it'll be a minus. But when dealing with complex numbers, your final results should always be in this standard form here. All right, and then once again, just to show you where things are on my TI-84 calculator, if you happen to have one, or a TI-83, very similar. Pull the calculator up. I'm going to enter the original expression the way it was. So you had the quantity 6 plus 2, and then the number I, the imaginary unit, is above the decimal point. You have to hit the second button. There's I. So 6 plus 2i plus, and then the quantity 3 minus 4i. And look, see 9 minus 2i, like I had here. So it works. We did a good job. Easy to check on a calculator, especially if your calculator actually has the ability to show complex numbers, show imaginaries. Alright, and that'll be the last one I check with the calculator. Alright, I'll leave the rest for you to try, you to check out. Okay, question 4 is number 420 in the text. So again, it's just a big sum. Right, it's just a big sum. We have a positive 7, and then a plus negative 2, so 7 minus 2 for the when I'm combining the real numbers. And then we have a negative 4i term, and then plus negative 6i, so minus 6i. All I'm doing is rearranging the sum, rearranging the terms in the sum, so that the reals are next to each other and the imaginaries are next to each other. That's all I'm doing. And 7 minus 2 is 5, right? 7 plus negative 2, 5. And then negative 4i plus negative 6i is negative 10i. Right? And there we go. And that's in that standard form, real number plus imaginary number. 5 minus 10i. Very, very simple. Okay. Next question. Now this has subtraction. Now remember, when you're subtracting something with multiple terms, you're subtracting each term, right? Not just the first term. So be careful with subtraction. So again, I'm just going to rewrite this big sum here. Just rearrange the terms. So we have 8 and then minus 3, right? Minus 3. And then here we have negative 4i, right? I put the reals together, and we put the imaginaries next to each other. Negative 4i minus positive 7i, so minus 7i. Right? Don't forget to distribute the negative. And then combining the reals, 8 minus 3 is 5. Combine the imaginaries, negative 4i minus 7i is negative 11i. So you end up with 5 minus 11i, and those don't go together. And again, I leave it to you to check with the calculator. Alright, very, very simple, in my opinion. Alright, next question. Number 6 is exercise 424. Same thing here, right? I'm subtracting an expression with multiple terms. So that means, you're subtracting each of those terms. Alright, and once again, I'm going to rearrange the terms. So I have reals with reals and imaginaries with imaginaries. So going from left to right here, we have negative 2. That's not real, 5i. And then we have minus negative 5. Minus negative 5 would be plus 5. So there's the reals. And the imaginaries, you have positive 5i term, then minus 6i after distributing the negative. And now I combine the reals with reals, imaginaries with imaginaries. Negative 2 plus 5 is 3. 5i minus 6i is minus 1i, or just 3 minus I. And again, I leave it to you to check. Great. Alright, the next question, number 7, exercise 426. We see these square roots of negatives. As I said at the top of the video, right? Whenever we see the square root of a negative number, you're gonna think about this automatic, right? Rewrite it. Now this would be the square root of 64 times I, or 8 times I. All right, the square root of negative 64 is 8 times I. So that's that number rewritten with the imaginary unit I, plus, and then this number we have 5, that's real, minus the square root of negative 16 is imaginary. And I'm going to rewrite that as the square root of positive 16 times I. Well, that's 4 times I. Right. Okay, so before I do anything, before I do any calculations at all, any square root of a negative I'm going to automatically rewrite using the imaginary unit I. Alright, and then once again I'm going to rearrange the terms of this sum so that we have reals next to reals and imaginaries next to imaginaries. So we have negative 3 plus 5, the reals, positive 8i is a term, and then plus negative 4i would just be minus 4i. And then combining the reals, negative 3 plus 5 is 2. 8i minus 4i is positive 4i. So this ends up being equivalent to 2 plus 4i. Great. And again, I leave it to you to check. And this is the final question of this video, final example, example 8. This is number 428 in the text. So once again, I'm going to rewrite these square roots of negatives as imaginaries. So these are a little trickier. I'll do these off to the side. The square root of negative 27, alright, that would be the square root of positive 27, a real number, times I, making it imaginary. And then the square root of 27 is the square root of 9 times the square root of 3. That's 3 times the square root of 3. Alright, so that's 3 times the square root of 3 times I as an imaginary with that imaginary unit. I'm also seeing the square root of negative 48. So I'm going to rewrite that as well, right, as the square root of positive 48 times I. And this is the square root of 16 times the square root of 3. So 4 times the square root of 3 times I. Okay? So first thing I'm going to do is, again, rewrite these square roots of negatives as imaginaries. So this is negative 5 plus 3 times the square root of 3 times I. Then we have minus, and then this number here is negative 4 minus the square root of negative 48, as I wrote over here, is 4 times the square root of 3 times I. And don't forget to distribute this negative, right? We're subtracting a number with multiple terms. So you distribute the minus 1, right? Subtract each term. And then I'm going to rearrange the numbers again. I'm going to rearrange the terms so we get reals with reals and imaginaries with imaginaries. So we have negative 5 minus negative 4. That'd be plus 4. All right. And then the imaginaries, you have positive, 3 times the square root of 3 times I. And then minus negative 4 times the square root of 3 times I. That'd be plus, right? Plus 4 times the square root of 3 times I. And then combining the reals, negative 5 plus 4 is negative 1. And then combining the imaginary numbers, 3 root 3 plus 4 root 3 would be 7 root 3. Those are like radicals. All right, those go together. 7 times the square root of 3. And then times I. Don't forget the I, right? Those are both imaginary. You add imaginaries to make another imaginary. And there we go. That's it. Here's the final result in that standard form, A plus BI. Negative 1, the real number, plus 7 times the square root of 3 times I, the imaginary number. And again, I leave it to you to check, with a calculator if you have one that's capable of doing it. Great. So again, easy enough. And I'll say this again because it's very important. Whenever you see the square roots of negatives, like in these two problems here, change it to an imaginary number straight away before doing any calculations. It'll make things that much easier for you in the long run, I promise. Wonderful. Alright, so that's it for this video. I'm hoping that watching me go through these 8 questions here help you out in some way when you're asked to add or subtract complex numbers on your own. And thank you very much for watching.